Motion under gravity. Let's go to motion under gravity. Motion under gravity. Okay, so let's just go ahead and do one or two things to the equation. So we'll just say equation 1 now becomes what? Equation 1 become V is equals to what? U plus or minus GT. And equation 2 now becomes H is equals to what? UT plus or minus half GT squared. Equation 3 now becomes V squared is equals to U squared plus or minus 2GH. As you can see, look at it very well and notice the difference between the normal motion equation and this one under gravity. So we can see that if we look closely, we see that G for this equations here, G is equals to what? G is equals to A as in the other equation, and H now represents what? S. That's the difference. So where H is the height, say H is equals to the height, and what? G is equals to what? Acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity. I believe it's clear. Which we do approximately take it as 10 is the power. Okay, just like that. That's what we do take it as, and it serves like a constant. So vertical projection, let me just go ahead and take a vertical projection. Vertical projection. So when you have a ball thrown upward, let's just say like this, it will reach a maximum height where the force is overcome by the force of gravity, the force which was used to propel the ball. So we'll just say this is U, and at this height we'll say this one is what? This is the maximum height. So we'll just say H max. So when you look at it closely, you will see that that's how it is when you throw a ball upward vertically. So from here we'll just say final velocity now. The final velocity at this point is what? Is V, and it is equals to 0 at that point. So we'll say at max, height is equals to what? At maximum height, final velocity is equals to 0. So that does it for that. So H max is the maximum height attained, U initial upward gravity, and G acceleration due to gravity. So time t taken to attain the maximum height will be obtained from the first equation of motion. Let's just say okay, when you say V is equals to U minus GT, alright, like that. So from this we're saying that V is equals to 0, right? We're saying that V is equals to 0, so we'll just have it that V is equals to 0, U minus GT. So from this equation now we'll see that U is equals to what? GT, and time t is equals to what? u over g, right? So equals to initial velocity over acceleration due to gravity. So the total time of flight is going to be 2t, because for it to go this way and come back down, so we'll say it's 2t. So 2t now is equals to what? That's capital T, which now is equals to what? 2u over g. That's the total time of flight. The total time of flight. So we'll go ahead now and say the time taken to reach the maximum height. Okay. Let's just say we're going to talk about the maximum height now. H max. All right, that's the maximum height. That's how we represent it. So that can be gotten from the third equation of motion, which says that equals to v squared equals to u squared minus 2gh. all right, and that's the h max there. So we're going to look at it like that. At that h max, we know that v is equals to 0, as in the previous one. So we'll just say 0 is equals to what? U squared minus what? 2gh. So having that, we'll just go ahead and say u squared now is equals to what? 2gh. And now what we're going to do is just like we're just going to make h the subject of the formula from this equation. You can see it clearly. So let's just divide here by 2g and divide here by 2g. So when it cancels, we have h is equals to what? U squared over 2g. So we'll say h max. So that's what we're going to use to look for or solve problems that have to do with projection, vertical projections. And I believe it's clear, and maybe in my next video I'll show you how to do that. But for now, I'll just say bye.